Okay, now I'm going to look at word problem number 4. Word problem number 4 says that a Southwest Airlines jet achieves a liftoff speed of 112 meters per second in 20 seconds starting from rest. So BI is 0. VF is 112, but it's a negative 112 because it tells me that it's due west. And the time that it takes to achieve that velocity is 20.0 seconds. And they're going to ask you to find the acceleration. So acceleration is equal to VF minus VI over T. Acceleration is going to be a negative 112 meters per second minus 0 meters per second over 20.0 seconds. So my math is going to tell me when I take negative 112 divided by 20 that I'm going to get negative 5.6 meters per second squared. Then I'm going to box my correct answer. Please notice the format. I've listed the given. I've identified what I'm looking for. I've given the working equation. I've substituted in the numbers with units on every single number. And then I've boxed my correct answer. That's the format I am expecting from you guys. Okay, if we look at the fifth word problem, it says that we have a coin that is dropped from the top of the Sears Tower in Chicago. So the distance that it has to fall is 427 meters. If it's dropped, the initial speed is 0 meters per second. Gravity is going to accelerate it at 9.8 meters per second squared. And they want to know the final velocity of the coin when it gets to the ground. So that's what we're looking for. So my working equation is VF squared equals VI squared plus 2AD. I, however, know that VI is 0 because it was given to me as being released. So VF is going to be the square root of 2 times a positive 9.8 because it's going back to the Earth, meters per second squared times 427 meters. So if I plug that in my calculator and take the square root, I got VF to be 91.5 meters per second. So there's number 5. Number 6. Number 6 says 2 Tiger runners. Well, at CSHS it would be Cougar runners. Complete a mile in 3:52:46 and 3:52:72. Assuming they both run with at their average speed during the entire race, what distance separates them at the end of the race? So I said, well, what's going to separate them is how much time has elapsed for the faster of the 2 runners and how much he got ahead. So I said, well, I'm going to take that 3 minutes and 52.72 seconds, and I'm going to convert that to that was minutes, I'm sorry. So I wanted to get that all in one uniform time. So when I did that, if I could figure out what I did, I think that I got 232.72 seconds for that one, for the other runner. I got 232.46. So the faster runner was ahead by 0.26 seconds. And then I said, well, that was the delta T that separated them. And then I said, well, the average speed for that runner is 1,609 meters in 232.46 seconds. So I calculated the average speed for that gentleman to be 6.92 meters per second. And he ran at 6.92 meters per second. And he finished in 0.26 seconds less than the slower of the 2. So when I multiplied those together, I got 1.7992 as the distance of separation, or 1.8. Okay, the 7th one. The 7th one says that at the beginning of a Lady Tiger basketball game, a referee tosses the ball up straight up with an initial speed of 4.60 meters per second. Rises to the highest place. Speed goes to 0. Gravity was negative 9.8. And then it says a player cannot touch the ball until it reaches its maximum height and begins to fall down. What's the minimum amount of time that a player must wait before touching the ball? So basically we're looking to see how long did it take for the ball to reach its highest point. So time is equal to VF minus VI over A. And I got that from A is equal to VF minus VI over T. I rearranged it. So 0 meters per second minus 4.60 meters per second over negative 9.8 meters per second squared. So when I did that, I got that time to be 0.469 seconds. Okay, question 8 has to do with a Volkswagen Beetle. The acceleration of the Beetle is 2.50 meters per second squared. Both the acceleration and the velocity of the VW point in the same direction. How much time is required to go from 21 to 31? So for part A, VI is 21. VF is 31. And they want to know how much time is taken. Well, I said time again is VF minus VI over A. So 31. Again, every number gets a unit. 21 for the initial, divided by an acceleration of 2.50 meters per second squared. So it took 4 seconds. And if you look at part B, the change in velocity is identical. It goes from 51 to 61, so it changed by 10. So it's going to look just like this math. This will be 10, and this is 2.5, so that's 4 seconds also. All right, number 9. Number 9 says the Endeavour shuttle travels at a speed of about 7.6 times 10 to the 3rd meters per second, so its average speed is 7.60 times 10 to the 3rd meters per second. And it wants to know how far is it going to travel in the blink of an eye, how many football fields. Well, the blink of an eye is 110 milliseconds, which is 0.110 seconds, and we want to know the distance. Well, distance is equal to average speed times time. So that's 7.60 times 10 to the 3rd meters per second times 0.110 seconds. So the distance that I got when I made that calculation happen was 836 meters. But they don't want it in meters, they want it in football field lengths. So one field, according to the problem, is 91.4 meters. So I'm going to convert that into fields, and I got 9.1 football fields. All right, number 10. Number 10 says that we have a water balloon that's launched straight up. So it's going to go up like that with an initial speed of 50 meters per second. You know that gravity's pulling it back to the earth, or attempting to, at 9.8 meters per second squared. I'm going to make that negative. It's going to reach its highest point, and its final speed is going to be 0. And then it's going to begin to fall back down with an initial speed of 0. And the gravity on the way down I'm going to call positive 9.8 meters per second squared. So that's my givens. All right, so on the descent, a slight breeze blows the balloon laterally and it strikes a tree limb that is 30 meters above the ground, missing the intended target. Determine the velocity of the balloon when it bursts on the tree limb. So down here somewhere, 30 meters above the ground is a tree limb. So what I'm going to do is I'm going to go back and figure out a couple of things about the rising and the falling of the balloon. So I said, well, let's see how high it rises. So the distance that it rises is equal to 1/2 AT squared plus VIT. So that's 1/2. A on the way up is negative 9.8. T I don't have yet. VI was 50. So it looks like I need to go solve for my time. Well, that's pretty easy to do. I have time is equal to VF minus VI over A. So VF would be 0 at the highest point. VI is 50. And A on the way up is a negative 9.8. So it must have gone up for, let me see what I got when I did that math. Hang on, let me find my time somewhere. Doesn't look like I solved for the time. Looks like I took a different approach. So I'm going to pause and see if I can find the time, and then I'll come back. Okay, so I went and calculated the time. I took a different approach when I did my solutions, and then I started talking about this approach when I made the recording. So we're going to put 5.1 seconds here, and we're going to put 5.1 seconds here. Don't forget to square it. So the distance that it rises, according to my calculations, was 127.55 meters. Okay, so it rises up 127.55 meters. It begins to fall, and since it hits the tree 30 meters above the ground, the distance it fell is 127.55 meters minus the 30 that it is still above the ground, so it fell 97.55 meters. So I can do VF squared equals VI squared plus 2AD and solve for the speed that it has when it hits the limb. If it's beginning to fall, VI is 0, so that's going to be 2. A is positive 9.8, and it fell 97.55 meters. So I got VF to be the square root of that number. And when I did the square root of that number, I got 43.7 meters per second. So there we go. All right, I'm going to stop this recording, and then I'll come back and do another one.